So, good evening, everyone. We will wait for at least 5 minutes so that everyone can able to join the session. So, okay, let's start the session. So, good evening, everyone. I hope I'm audible and visible. If not, so any one of you can confirm it. Okay, hello everyone. My name is Pooja Verma. I'm PMRS Research Scholar from IIT Kharagpur. And the instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a week 5 live and interactive session on computer vision. So this is a week 5. So I hope all of you have gone this week video lecture. So here we will solve some numerical questions which will be very similar to your assignment problem so that you can able to solve these questions. So for this week, the course content is also stereogeometry and this is the last part. Last after that, the feature detection and matching will start. So for imaging system, this is the last course content on stereogeometry. So here we will solve some problem. Okay, I will give in the later part of this session. Okay, okay. So let's solve some numerical problems. So question one is, yeah. So question one is the general formula for a pair of canonical camera matrices corresponding to F is given by P, and P is given by this canonical form, that is I given 0, and P dash is represented by E dash X into F plus E dash B transpose given lambda E dash. Okay. And where E dash is the right null vector of F given as -1, 0, 1, lambda is a non-zero scalar, and V is a 3D vector. Given a fundamental matrix F, compute the canonical camera matrices P and P dash corresponding to F. Consider a 3D vector as 1, 1, 1. So here, what we need to compute P and P dash corresponding to the vector to the fundamental matrix F. So let's solve this problem. I'm just taking one slide so that we can solve. Okay, so is it audible and visible now? Right? So if not, any one of you uh, can confirm it here.
Yes, ma'am, it is visible.
Okay. So question already we have read. Now we are moving to the solution, how we can solve it. So already fundamental matrix F, here it is given, that is -2, 2 and 2, -7, -2, -2, -2, 2 and 2. And the matrices P is given in the form of I given 0, right? And we have to compute P and P dash as well, and P dash can be calculated by this equation. Already it is given in the question. E dash X, already we know that it is a skew symmetry matrix corresponding to the right epipole E. F plus E dash V transpose given lambda E dash. So here already we know that right null vector of F is specified as E dash is also given by 1, -1, 0 and 1 transpose. Okay. and V is also given, that is 1, 1 and 1 transpose, and lambda should not equal to 0, right? So first what we need to do, we have to compute the P dash, right, for this expression. P is already given, it is given I given 0 form. So for computing the P dash, first we need to calculate this E dash X part, right? So E dash X we are computing with respect to this one, E dash, right? So what is the formula already, as we know that? So anyone of you can tell how we can represent with E dash X with respect to E? What is the matrix? Already we have solved many times. So here it is a sorry, 0. And if we are writing in terms of A, B, C, this one A, B, C, or E, X, E, Y, E, Z, you can write in any term. So here just I am taking a B, C. So here minus C, B, here C, 0, minus A, minus B, A, and 0. So already we know that the value of A is minus 1. Here value of B is 0 and value of C is 1. So just put in this matrix equation, you will get E dash X with corresponding to this vector E dash. So 0, minus 1 and 0. Here 1, 0, 1, because it is minus 1 and the minus is 1, plus 1 will be there. And next one is minus B, that is a 0. Here A is minus 1 and then 0. So E dash X we have just calculated or computed. Now next one is what we need to calculate, E dash X with multiplication with the fundamental matrix F, the next step. So first step is this. Now next step you can say that E dash X into F, right? So already we got this matrix 0, minus 1, 0, 1, 0, 1, 0, minus 1, 0, no? Minus 2, 2, here 2, minus 7, minus 2, minus 2, here again minus 2, 2 and 2. Now we have to just multiply these two matrices. So can you multiply these two matrices? Okay, so let's multiply these two matrices. So first row, then column, then this first row, second column, and this first row, third column for the third element. Okay, so in the here, these two are 0, so minus 1 multiplied by minus 7. So 7 only it is here. Similarly for the next also, here you will get 2. For this one is also, you will get only 2. Now multiply the second row with all these the fundamental matrix column. So you will see, so minus 1. Here the second column is, it is a 0. So here it will be 0. So minus 2 and minus 2. So it you will get minus 4, right? Now the for next one also you will get 4, because 2 plus 2, again next value is 2, 2 plus 2, it will be the 4 only. Now next the last row with all these three columns, just multiply and add, you will get here 7, because here minus 1, minus 7, so minus 7 only. Next one is also 2 and 2, you will get this one, E dash X into F, you will get this matrix. Now next step is calculate this value, E dash V transpose. Right, so E dash it is given here and V already it is given in the question. So just calculate it. So I am writing it here as a third step. So E dash, yeah, just a minute. Yeah, E dash V transpose, right? So how we can multiply E dash? Here it is given minus 1, 0 and 1, and V transpose, so opposite of it. So we will get 1, 1 and 1, right? Now if you multiply these two, so this we can say that this is the first row, second row and third row, right? And one column is there. So which matrices you will get? So can you tell me what matrix you will get? Matrix you will get here. So here this minus 1 will be multiplied to all the here. Yeah, 3 cos 3. Correct. So here we will get minus 1, again minus 1 and minus 1, and in the next row you will get 0 because this will multiply all these three columns. 0, 0, again 1, 1 and 1. Now you have got these two, when E dash xf plus E dash P transpose. Given lambda E dash, we have to calculate. So first we need to add these two matrices. Okay, so I can take another slide or I can remove it. Okay, I can take another slide. So now we have to add, we have to calculate at the end E dash, that is equal to E dash x into F plus E dash V transpose given lambda E dash. Right, so these two we have calculated, so just add these two matrices. So E dash x into F we have got, that is 7, 2, 2, and next is minus 4, 4 and 4, 7, 2, 2 plus this one. So that it is here only. So minus 1 and minus 1, 0, 0, 0, 1, 1, 1. Now after addition or subtraction, just do these two matrices, add these two matrices, we will get 6, 1 and 1. Here it is same, minus 4, 4, 4, again 8, 3 and 3, right? So this part you have got. Now next part is lambda E dash. We have to calculate. So lambda is a constant, or it is lambda is not, should not be equal to 0. It is given, and E dash already given. It is minus 1, 0, 1. So here you will get minus lambda, 0 and lambda. So what we can write it? The whole matrices P dash we have to write in this form itself. So 6, 1, 1 minus 4, 4, 4, 8, 3, 3 given minus lambda, 0 and lambda. And lambda should not equal to 0. It is given. So we can represent it in this canonical form. Okay, so let's check with the options. Okay, so here everything is painting here. So just a minute. Let me do. So from the this one you can say that no equations are matching with this one. So some problem is happening. So let me close it once, then again I will share it. So just a minute. So now it's visible. Now screen is again visible to all of you. Okay. So the answer that we have got, that is 611. I'm just writing, we have solved it here. So what we have got, P dash we have got 611 minus 4, 4 and 4. Now next is 833 given minus lambda 0 and lambda, right? And already here it is given by P is given, P I given 0 and lambda, so a non-zero scalar. So lambda, we don't need to compute lambda. So from the options, we can see that none of the above options are matching with our answer. So option D is the correct answer for this question. Okay. So have you understand this question? Already everything is given. Now we need to put in this equation all these values because fundamental matrix is given. E dash is given here. The right where E dash is the right null vector of F. It is given and vector is also given, that is 1 1 1. Okay, just we need to put in this equation and just calculate all these values and put into the matrix form. So we will. Okay, so I hope you have understand this question. So moving to the next question. Okay, so next question is, consider a plane induced homography H. The homography matrix is given as a stereo imaging setup. Epipole E dash 5 7 in the right image plane and a point X 3 1 in the left image plane are given. Compute epipolar line L dash on which the corresponding point of X will lie in the right image plane. So how we can move with this question? So as we know that the epipolar line L dash in the right image plane corresponding to a point X, it is given in the left image plane, that can be computed. First, we need to represent this given 2D image point into the homogeneous form, right? So to represent the homogeneous form, already we know that. So to represent the homogeneous form to E dash, that is in homogeneous form, homogeneous form. So we can represent the E dash, that is right image plane 5, 7, 1. Similarly, the left image plane is also we can represent in the homogeneous form, that is 3, 1, 1. Now, first what we need to do, we need to compute epipolar line L dash, right? So to compute the epipolar line L dash, the epipolar line L dash is computed by E dash multiplied by X dash. Here it is a not a dash, it is a simple X. Okay. Now how we can compute the X dash? So X dash can be obtained by applying homography to X. X dash we can compute by applying homography to the left image plane, that is H into X. Okay. So first we will calculate the X dash, then we will just calculate the epipolar line L dash, that is calculated by cross product of E dash into X dash. So H dash is already given. So I'm just taking another slide and calculating that one. So H into X. So H is given as 2, 3, 1, 4, 5, 2, 2, 1, 2. Right? This is the homography matrix H. And then now the left image plane X is given as in the homogeneous form. Already we have 3, 1, 1. Now if we multiply these two, we will get X dash. So what will the next matrix we will get? The first row, and this column is the first row of the next matrix, right? So 6 plus 3 plus 1. Now next again 12 plus 5 plus 2. Now next is 6 plus 1 plus 2, right? What will be the values? Yeah, I hope someone has calculated. Yeah, 10, 17, right. It's 9, 6. So if 10, here 4 3 is 12 plus 5 plus 2, right? So it will be the 19. Now next it is 9. Okay, 10, 19 and 9 you will get. Now the epipolar line L dash we can calculate it by L dash E dash into cross product of X dash. So how we can calculate it, the cross product, that is I, J and K. So E dash, what is the values of the E dash? 5, 7, 1, right? 5, 7, 1. And X dash we have calculated 10, 19 and 9, right? So can you calculate and let me know what will be the values you will get for I, J and K? And that will be the values of in the corresponding values with respect to I, J, K, that are the epipolar lines values. So I, here it will be the just cross multiplication of these two columns, right? If we remove first row and first column, so 63 minus 19, right? Now next one is minus J. Now just remove the second column first row and just cross multiplication of these two. So 45 minus 10. plus k. So just remove first row and last column. So 10, 5 into 19. What will be the value? 95 minus 70, right? If you just subtract it, you will get 44i minus 35j, and here 25k, right? That is the epipolar line L dash. So we can represent it in a vector form, right? So if we represent it into a vector form, you will get 44 minus 35, 25. If you again want to, if just check with the question, if they are asking in the 2D image plane, it is a representation in the homogeneous. So just divide all these two into a divided by 25. So this will be the in the 2D image plane again. So here it is given in this homogeneous form only. So just check with the answer. So you will get 45 minus 35 and 25. So option B is the correct answer with this for this answer for this question. Okay. So answer B is the correct answer. Okay. So I hope you have understand this question. So now moving to the next question. Yeah. Okay. So now next question is here question number 3. Consider the top left element of a matrix is denoted as 1 1. Row and column indices increase from the top to bottom and left to right respectively. Plane induced homography H between left and right image plane of a stereo imaging setup is given by H, that is a matrix, and two point correspondents are given as x1 1 2 and x2 is 3 4, and x1 dash is 5 1 and x2 dash 6 3. Here points x and x dash are the 2D point on the left and in right image planes. Compute fundamental matrix F corresponding to this stereo imaging setup with the element in the third row and third column of 2B1. So here we have to note down this point first. So the element in the third row and third column of the F to be 1. That means this one. So in the early one is it is 1. So we can write it F33 must be equal to 1. Whatever fundamental matrix we need to compute it. Okay. So the induced homography matrix H and the two point image points are also given in the both left and right image plane. So already we know that the fundamental matrix F is calculated by E dash X into H, right? And it is calculated by this one, and E dash X already we know that the skew symmetric matrix corresponding the right epipole E dash. Okay, so that is calculated by minus E3, E2, E3 0 minus E1, so minus E2, E1 and 0. So first we have to represent all these points in a homogeneous coordinate. Okay, all the left and right image point we need to represent in the homogeneous coordinate. Left and right image points in homogeneous coordinates, right? So first one is x1, we can say that It can be represented by 1 to 1, and x2 is 3, 4, and 1. Similarly for x1 dash, that is 5, 1, and 1. Now x2 dash is 6, 3, 1. Right? So all the points we have represented into the homogeneous coordinates. Now what will be the our next step? So already it is given that normalization constant, that f, that is last third row and third column, that is f33, must be equal to 1. So the epipolar constant for the two given correspondents, how we can calculate the epipolar constant? Let me take one slide. Okay, so epipolar constant for the given two correspondents is f, that is calculated by e dash x into h. Already we know that. Okay, so first here, so already we know that it is x dash transpose f, x is equal to 0, that for x comma x dash point, right? Here but two points are given, x1, x2, for the right, left and right miscellaneous, so we have to calculate for both. Okay, so just we have to calculate this one also, x dash transpose f, x is equal to 0. Okay, so one way we can solve it just by taking 0 minus e3, e2, e3 0 minus e1 minus e2, e1, e0. This is a representation, and induced homography matrix it is given, right? So 4, 4, 6, 3, 5, 7, 2, 6, 9. So can you multiply and let me know what will be the equations or what will the next matrix will be formed? Okay. So when you multiply, the next matrix here will be formed. And from there, you have to calculate the values associated by this equation 1, E1, E2, and E3 values. Okay. So this will be going to a very, very large. So what we can do, the other way to solve this question, just go with the options, right? So whatever constants and whatever the values it is given, we can cross check with the options. So here, this way you can solve it later because it is very large. Other way, I'm just telling you, I'm just telling you this way also, because if there is a comprehensive type question will come, so you have to solve it like this one. You can't go by options. If it is a multiple choice question, so just you can check with the options. Okay. So if you want, I can calculate all these values also. Already I have calculated. Or first I will go with the options, then we will calculate it. So what you want? Should you need this one? Should I
Go
need to
with
calculate?
options, ma'am. You can.
First we will go with the options. If you want this comprehensive, okay, first
It's okay, ma'am.
opinion. Okay, so I am just going with the options. So other way. So okay, so already the key relation, I should write it here also. This one also. So already we know that x dash transpose f x is equal to 0. Already it is already we know that if the two image points are given. Okay, and homogeneous representation already we know that. So what we can do, we will test by options with this equation. Okay, so just I'm taking one slide and solve with this one. So already we know that we can represent it like this: x1 dash transpose f x1 dash. That relation already we know that this is holding f dash x, it is equal to 0 from this relation. So x1 we know that, and just we can go take the f, that is fundamental matrix, from the option. Just go with the option, just multiply these values and check. If it is 0 is coming, that means that will be the answer. If 0 is not coming by the all this multiplication, that means that option is incorrect, right? So what is our x1 dash? 511, right? So x1 dash transpose, we can write it like 511. Yeah, someone, you have any query? Yeah, you can ask.
Yeah, madam, in the question for x2, it is given only 3 comma 4. How you take the third element as 1 in the matrix, ma'am? Column.
Okay, so when we are representing this 2D image point into a homogeneous, so how we are representing any point xy, just a minute. Any point xy, how we can represent into a homogeneous coordinate. So it is a homogeneous coordinate. So it is a homogeneous coordinate, homogeneous representation of any 2D image point x, y, 1. So that's what we have represented all the 2D image point into the homogeneous coordinate. So that's why we have added 1 as a
It's
third element. Okay.
it's okay, ma'am. Thank you.
So here our F is given as here for option A. Just note it down the for option A, 23.58 minus 3.73, and we need to multiply this one. Okay. So x1 dash transpose, it is given, and just take F from the option A, 23.58 minus 3.73 and minus 14.53. Now next is minus 45.18, 67.44 and 11.17, and here 22.59 minus 13.71 and 1. Okay, now next one is x1. So our x1 is 1 to 1, right? So 1 to 1, and that should be equal to 0 when we multiply all these values. So first we will multiply these two, then multiply with this one. Okay, so just can you multiply and let me know what will be the values? So 23.58 minus, if you 2 into 3.73, if you multiply, you will get 7.46, then again minus 14.53. Okay, similarly for the next also, minus 45.18 plus 134.88 plus 11.17. Now next one is 22.59 minus, here you will get 27.42 plus 1. So again, if you just add and subtract, you will get here 1.59, 100.87 and minus 3.83. And again, just you have to multiply with this matrix. So you can just multiply 5 into 1.59, you will get 7.95 plus 100.87 minus 3.83. So that is equal to 101.04. And from here we can say that it is not equal to 0, right? That means if you calculate for the second left x2 also, you will not get 0. If you are getting, then but here for x1 it is not coming 0. So just discard option A. That means option A is not a correct answer. Now just check with the option B and C, same in the same way. Then whatever option is giving satisfying this equation, that means that is the correct fundamental metric. Okay. If not, then none of the above option will be the correct one. So should I just go through with the all options or just the correct one? So have you got this one? How you can solve with the options? Or otherwise you have to just calculate all the values of E1, E2, E3. Just again put in that equation and you will get the final fundamental matrix. Now I'm going with the option B because here A, B, C in the only three options F value is given. Then so you can easily calculate if it is not coming equal to 0, that means none of the above option is the correct one. Okay. Okay. So I'm going with the option B itself 5, 1, 1. Now fundamental matrix in the option B it is given as, so I'm just writing it 2.58 minus 3.73 minus 4.53 minus 45.18 7.4 1.17 here 2.59 minus 3.71 and 1. And for this one it is already we know that 1 to 1 equal to 0. Yeah. So is it not audible?
It's okay, ma'am. Now it's okay, ma'am.
Okay.
Thank you, ma'am.
Okay. So just first multiply these two matrices, then multiply with this one. So I am just writing these values. So already I have calculated. Okay. So here you can just 2.58 minus here again you will get minus 7.46 minus 4.53. Okay. For similarly here again minus 45.18 plus 14.8, here it is plus, yeah, plus 1.17. So just let me check, yeah, 1.17, and here it is also 2.59 minus 7.42 plus 1. Okay, yeah. So if you just subtract and add these values, you will get the value of here you will get, yeah, minus 9.41. Here you will get 15, 29.21 approximately. So just take with this one. And here you will get minus 3.83. If you multiply these two, you will get minus 47.05. Again minus all the minus values. So 29.21 minus 3.83. So if you just calculate it, you will get 80.09. And Option B is also not matching, it is not equal to 0. So that means option B is also not a correct option. Okay, now just go with the option C. So option A and option B has been discarded. Now check with the option C. So can you calculate and let me know what will be the answer for option C? Can you calculate with me? Option C. For option C, what will be the fundamental matrix for option C? Here it is given 22.58 minus 3.73 minus 14.53. Okay, so just I am writing all these values and calculate it. 22.58 minus 3.73 minus 14.53. Here the next value is minus 45.18, 7.44, and next one is 11.17. Here 22.59 minus 3.71 and 1. So just check for this option as well. 5, 1 and 1. So just if you multiply these two matrices, you will get 22.58 minus 7.46 minus 14.53. For the next row, you will get minus 45.18 plus 14.88 plus 11.17. For the next one, we will get 22.59 minus 7.42 plus 1. Okay. Now again, just need to add and subtract this. We will get here 0.59 minus 19.13 and 16.17. And now again, you have to multiply with this one. So what value you will get? Here you will get 2.95 minus 19.13 plus 16.17. Okay. So here, if you add this one, so approximate these values, if you add these two, so 16 plus to 18, and here 19 point, some values will be here. So 19.12 here, 11 minus 19.13. So that approximately it will be the cancel out. If you take some, I mean, because we are calculating the point, so that is approximately equal to 0. You can just, or you can say 0.01 you are getting minus. So it is approximately equal to 0. And also it is said that F33 must be equal to 1. This constraint is also completing with this F matrix. So you can say that, and also you can just multiply with the x2 also, x2 transpose F x2. That will also give equal to a 0 value. Okay, you just calculate it. So from here you can say that option C is the correct answer for this question. This F matrix will be satisfying all the constraints for the given image point and induced homography matrix. Okay. So other option already I have told you how to calculate. That will be a very long process. That is also not suitable for the objective type questions. So if it is objective type, yes, you can ask.
Madam, but none of the above option is also there, ma'am. But we are approximately equal to 0. How can we conclude that C is the right answer, ma'am?
See, if you just take, if you are calculating that we what value we have got minus, let me see. So here 19.12 and here it is a 19.13. But here if you take any here in the place of 9 or something, so it is a just point calculation. So it is very less 0.01. So from here it is if it is coming that much less you can just calculate it 0. And also you have to check for x2 transpose f x2 also. If it is also giving the 0, then you can say that okay, option C is the correct answer. And in the first two options already you have seen that we are getting very large values. That is not equal to 0. In the minus very large or other thing. So it is coming approximately 0. Just you have to point 0.001 difference is there. So if you just recalculate or something in the calculator, that will be the equal to 0 only. Okay.
Okay, ma'am. Okay, ma'am. Thank you.
So other way if you want, you can solve that way also. Already, as I have told you, just multiply these two matrices, make the equation and solve these equations for E1, E2 and E3 values and just put in this equation in this what equation here you will get, and then finally you will get the fundamental matrix. Okay. So this is the one way. Another way to go with the options. So whatever suitable for you, you can just go with that. Okay. So if you want, I can solve this one also this way also, but it will take some time. If you want this
It's
way
okay, ma'am. Go
also.
to next problem, ma'am. Well,
Okay.
anyways, we can. I think better to go for next problem, ma'am.
Okay. No, if some other person wants to solve this way also, so I
Yeah, yeah.
can
Please.
also. Okay. Okay. So moving to the next problem. So now next problem is computer homography induced by a plane at infinity S infinity or camera matrices P. So how we can compute that H infinity values? So you have calculated this type of problem. So can you suggest something how we can solve this question? So to calculate the homography induced by a plane at H infinity, that is already we know that K dash R K inverse, right? This is the formula. K inverse. It is a K inverse to calculate the homography induced by the plane at infinity relates image at the same 3D points under two camera projected onto pi infinity. And where already we know that where K and K dash are the intrinsic matrices. Intrinsic matrices of P and P dash. So here P and P dash is given. So already we know that P and P dash we can represent in this form also. M given M4, right? Or we can just represent it M also. And similarly for P dash also, M dash given M4 dash, or we can say that M dash. So how we can represent it? So just in this form, right? It is a 4 cross 3 matrix. So if you want to represent in this form 417 252 890, it is a M, and for M dash similarly we can represent it like 446 357 and 269, right? So here, okay, sorry, or you can say that K, it is a representation of K, or here you can write it M or M dash inverse. Okay. So just avoiding the confusion, I can write here this M, M inverse, out here M, and M is the intrinsic matrices of the P and P dash. Okay. Now what we need to calculate this one, first we need to calculate the M inverse, right? So how we can calculate M inverse? So already we know that 1 by determinant of M into adjoint of M. So can you calculate the determinant of M and let me know in the chat box? Okay, so just I'm waiting for some few seconds, then I will calculate the determinant of M and the whole M inverse matrix. I know that in this short time you can't calculate the M inverse, so I will be right here. Already I have calculated, because for that you have to calculate the cofactors and take their transpose. Then you will get the whole inverse matrix. So determinant at least we can calculate for M, this one, this matrix. It is M dash into M inverse is here. Okay, 264. Okay, let's see that what value I will get. So M matrix is M is given as 4 1 7 2 5 2 8 9 0. Right? This one is our M matrix. So determinant of M is 4. Here first just remove this one. We will get 0 minus 18 minus 1, right? Just first row and second column removing. 0 minus 16 plus 7. Just remove first row and last column. Cross multiplication of this to 18 minus, what will be the value? 40, right? Okay, okay, no issues. At least you have tried. So here we will get 4 into minus 18 minus 1 into 16. So I can write it here directly plus 16 plus, or here 18 minus 40. What will you will get? 18 minus 40. What will be the value?
But 22, ma'am.
Yes, 22 into 7. So just you multiply, right? Minus 72 plus 16. Okay, so this is the
154,
value
yes.
we will get. So what will be the final one? You will get minus 210, right? Just can you calculate and let me know? This is the value you will get, minus 210. Now the adjoint of M you will get. Okay, so now adjoint of M you will get cofactors and other things you can calculate. So here I'm just directly writing the cofactors of that and transpose of that one. 63 and minus 33 we will get 16 minus 56 and 6. Here you will get minus 22, minus 28 and 18. So m inverse that is calculated by 1 by determinant that we have got minus 210 and adjoint of this one, right? So I am just writing it here directly. So m inverse 1 minus 210, right? Now if you again multiply it in this metric, so you will get 3 by 35 here. Here you will get minus 3 by 10. Okay, here you will be getting 11.70.
So ma'am,
Okay,
how this adjacency is calculated? Adjacency.
yeah, what you are asking, actually your voice is not clear.
How this adjacency matrix is calculated?
Okay, so adjacency matrix is calculated by the cofactor of the all the rows and columns. Cofactor transpose. Cofactor of M transpose. So how you can calculate the cofactor? So should I tell that here? It is a very
Yes.
long one. So first you have to take this one out. Okay, just calculate this one, this values only. Okay, so here what you will get 0 minus 18, right? Just remove this one. So here the first cofactor you will get minus 18. Similarly calculate for this one again for this one. So just remove this one and this row, cross multiplication. Just you have to calculate for each row, each values cofactors. Okay, so corresponding and just put it in this form, rows and columns, then transpose that one. Okay, can you calculate it or should I?
Okay.
So
Thank you.
cofactor transpose, you will get the adjacency matrix of that matrix. And then M inverse, you have to 1 by determinant divided by multiplied by adjoint of that matrix. Okay. So already I have calculated because it is very lengthy and very long process. So it is not possible here to calculate with the calculator here and cover all the questions. In that case, we will not able to cover. So I have just calculated and writing here. You just calculate it. And in exam, you may be permitted a scientific calculator. So directly from the scientific calculator, you just calculate M inverse values by entering the matrix values. Okay, minus 8 by 105 here, 4 by 15 here, minus 1 by 35. Here you will get 11 by 105 and 2 by 15 minus 3 by 35. Okay. Now what you have to calculate the H infinity value, that is M dash M inverse. So M inverse you have calculated. M dash here it is given. This one, this matrix 446357. Just multiply these two matrices again. Okay. Then you will get. So I'm just writing it here and just showing you to just multiplying with this one. So 4, 4, 6 M dash values, 3, 5, 7 and 2, 6, 9, right? And M inverse. That is this one. Just multiply these two matrices and let me know what will be the values. Can you calculate it or should I write it here? Okay, so just removing this part. Okay, just multiply these two matrices, M dash and inverse, which is written here. So I am just writing these values here. So here you will get 2 by 3. Here again you will get 2 by 3. Yeah, it's 2 by 3. Just check with this one because here minus 3 by 35, 3 by 10. Okay, so just check with this answer. And here 64 divided by 105 we will get here 41.30, and here minus 19 by 70. Row into column, yeah, you can get it. 23 point divided by 35, here 11.5, here minus 22.35 we will get. So first row, this column, yeah, you can get it. First row, this column of addition of these three, then first row, second column addition, first row, third column addition, then this value you will get. Okay, so here you will get 0.667, here again 0.667, 0.609, yeah, and here you will get 1.366 something minus 0 point, here you will get 271, here you will get 0.657, here 2.2, here minus 0.628. So this is our n infinity value you will get. Just go and check with the options. So from here you can, option A is the only correct answer, 0.667, 0.66, you can say that, and 0 and this one. So option A is the correct answer. So to just calculate homography, induced homography,
Madam,
then yes,
excuse. Can we carry our own calculator to the exam, ma'am?
um,
Or we have to use the on-screen calculator?
I think the on-screen calculator is there. You just check with that one. I don't know because that much of, I mean, calculations are if there, then you have to calculate the physical calculator. Otherwise, that much calculation, how is it possible? They calculate M inverse values of three matrices, and the multiplication of 3 cross 3 matrices.
From your side, you please request the examiners, ma'am, to allow the calculators.
Okay, I
Thank
will
you.
ask once. If it is a comprehensive type questions, then I think they will allow. And if
Yeah.
it is not MCQ type questions, so for that,
Madam, yeah. So this much big calculations we have to do means on screen coming back and answering will take so much of time, ma'am.
yeah, that's a possibility. Okay, so now I hope you have got this question. Now moving to the next question. Okay, so now next question is the ray back projected from an image point in 2D space X. X is given as 1, 2, given point is by P is obtained by solving Px is equal to X, where X is the real world coordinate of the corresponding image point X. The one parameter family of solutions is of the form given by X lambda, that is given by X lambda, P pseudo X plus lambda C, where P plus is the pseudo inverse of P and C is the its null vector. Namely, camera center of the first camera defined by PC is equal to 0. The ray is parameterized by the scalar lambda. So here P and is pseudo inverse of P matrices P dash and C, that is camera center, it is given. So here the question is, can you identify 2 points on the ray? Points should be given in homogeneous form. Okay, so points should be given in the homogeneous form. So already we know that how to represent this point in the homogeneous form, just by adding 1 in the image 2D image point. Okay, so this is the homogeneous representation. Now we have to calculate this one, pseudo inverse of p x in plus lambda c, where lambda is, we have to calculate at the different lambda values. Basically lambda is equal to 0 and lambda is equal to infinite, because only two lambda points here it is given in the options. So just check with the options for what values we have to calculate. Okay, so here accordingly we will put the lambda values and calculate that one. So just I'm taking one slide and then we will calculate it. Okay, so the ray for the image point x is given 1, 2, and its homogeneous representation we can represent 1, 2 and 1, right? Now x lambda is given pseudo inverse x plus lambda c, right? So what we need to, first we need to calculate pseudo inverse plus x. First we will calculate these two. Okay, so pseudo inverse matrix it is, and the homogeneous representation of x is this. Just take a multiplication of these two. Then let's see what will be the values for the putting lambda is equal to 0 and lambda is equal to infinite. Okay, so just calculating these two values. So here it is given x lambda is equal to pseudo inverse of p into x plus lambda c, right? So first we need to calculate pseudo inverse of p into x. So this matrix is given. So the values is 0.125, 0.0625, and here it is 0.0625, 0.375 minus 0.3437, 0.875, again minus 0.3125, 0.125, minus 0.0625, here 0.125, 0.0625 minus 0.375, right? What is the homogeneous representation of x? That is given 1, 2, 1, right? It is simple multiplication of these two matrices. First two, this column, there is one column only, so there will be the one column matrix will be there, right? So just it is addition and multiply 0.125, 0.125 into 1 and 0.025 into 2. So again you will get 0.125, right? Yeah, and it is 1 multiplication, so 0.0625. Similarly here also 0.375 minus, here you will get 0.6874 plus 0.875. Now next one is minus 0.3125 plus, here you will get 0.250 minus again 0.0625. Here that last one 0.15 plus 0.125 minus 0.375. Just add and subtract these values. You will get 0.3125 here, right? 0.5626 here minus 0.125. Again here 0. Minus 0.125, right? Have you got these values? So if you normalize it, just can you divide these values to normalize? Divide all these values by minus 0.125 like 0.3125 divided by 0.125. Again here 0.5626 divided by minus 0.125. Here you will get 1. Here again you will get 1. So can you let me know what will be the values you will get here? Here if you just divide it, you will get minus 2.5. Here you will get minus 4.5, 1 and 1, right? So here pseudo of Px you have got plus lambda c is there. So now in the question what they have asked for lambda is equal to 0 and lambda is equal to infinite. We have to check for that. So if you put here in this question lambda is equal to 0, right? Here if you put lambda is equal to 0, so what you have got? So x lambda at you can say x0, you will get this matrix only minus 2.5 minus 4.5 1 1, right? Okay, so you have got this one at lambda is equal to 0. Now if you are putting lambda is equal to infinite, so what you will get at lambda is equal to 0. Now next we need to calculate for lambda is equal to infinite. So can I remove this part till here or take another slide? Okay, let me take another slide. These values is lambda at is equal to 0 at now next one is at lambda is equal to infinite, right? Because the equation is same, p pseudo inverse of p and x we have calculated these values are constant, and now we have to check for lambda is equal to 0 and lambda is equal to infinite as it is given in the options itself. So for that we have to calculate, and it is also given in the question. What can you identify these 2 points on the array? A point should be given in the homogeneous form. So that's why we have to divide it, and the parameterized scale we have to just vary lambda. Okay. Now, okay. So at lambda is equal to infinite. So already we know that the equation for the array is x lambda is equal to pseudo inverse x plus lambda c. It is there. As lambda tends to infinite, so the if we will put here the so or we can do the x infinite. So what values we have got? Minus 2.5, minus 4.5, 1 and 1. Here plus lambda, see where lambda is infinite, right? So the direction of the array is dominated by a vector c. So the point can be considered as a vector c itself. So or we can say that to represent the point in a homogeneous coordinate, we can normalize the expression this one by just divided by this one by lambda itself, because already we know that it is a what is a infinite, the how we can represent it 1 by 0, right? So we have to take it in the round for the homogeneous representation. So if we just divide this one with the lambda, so what it here c only left. Now here we can put the infinite values, right? So that will the whole value will be the 0, and here you will get c. So x at infinite you will get c only. So that's why at lambda is equal to infinite, the direction of the array is dominated by the vector c only. Vector c, or you can say the camera center c, and that point will be considered as the vector c itself. Okay, so at lambda is equal to infinite, so x infinite you will get c only, and for lambda is equal to 0, at lambda is equal to 0 you will get this value minus 2.5, minus 4.5, 1 and 1. Okay, so from here just you can check with this value. So only this value at lambda is equal to option A is only matching with this question. Sorry, with the solution. So option A is the correct answer for this question. So have you understand this question? Can we move to the next question? So many questions are there. So moving to the next question. So have you understand this question? Anyone have any doubt for this question? So simply you have to calculate the P pseudo inverse of P into x values, then we have to vary lambda is equal to 0 and lambda is equal to infinite. If lambda is equal to 0, so this value will be the 0. If lambda is equal to infinite, so this one will be the 0. Okay. So I hope all of you have got this question. Now moving to the next question. So next question is, suppose the motion of the camera is a pure translation with no rotation and no change in the internal parameters. One may assume that two cameras are, that is in this form, P is equal to K I given 0 and P dash K I given T. If the camera translation is parallel to the x-axis, then E dash, that is here it is given, E dash is 1, 0 and 0 transpose. Can you compute fundamental matrix from the given information? Can we calculate the fundamental matrix? So already here given the two camera matrices, translation parallel to the x-axis, the right. So translation parallel to the x-axis, and epipolar of the second image, you can say that E dash, and then E dash will you will get 1 0 0, right? So when two cameras are related to the pure translation T, so I can write it, when two cameras are related to the pure translation, no rotation is there, right? By pure translation, translation T, the fundamental matrix can be written as the matrix is F is equal to T x K inverse K dash. Okay, so K inverse K dash is this, so you can write T dash x. And already as we know that this is a representation of a skew symmetric matrix. How we are representing in this homogeneous image representation, the skew symmetric matrix. So it is written for the right epipolar, or here it is, you can see x 0 minus ez ey, right? Here ez 0 minus ex minus ex 0, right? Now you can write. So what are the values of e dash is given here, right? It is ex, it is ey, it is ez, right? So 0, again here 0, 0, we will get, because ey, ez values are 0, ez again 0, 0, ex is 1, so minus 1 will be there, here 0, 1, 0. Okay, so the skew symmetric matrix for that, and already we know that that is equal to the fundamental matrix. If the only, when two cameras are related by the only pure translation, no rotation is there, then you can calculate by this directly. Okay, so just tick with the answer which one is the correct one. So option C is matching 0, 0, 0, 0, 0, minus 1, 0, 1, 0. Okay, so option C is the only correct answer for this question. Okay, okay, so have you got it? Have you got this question? Okay, so
Can you repeat the last two steps, please?
yes, this one, F fundamental matrix. Okay, so here it is already given in the question that if when two cameras are related to only the pure translation, no with no rotation and no change in the internal parameter. Okay, so thus then fundamental matrix F is represented by this one. That T is the translation factor. You can say that we can write it. So Tx, and already we know that this is a skew symmetric matrix representation when we are representing in this way. K inverse K dash, where K inverse and K dash are the intrinsic parameter of this one, P and P dash, right? So here P and P dash, it is this one is not given, so that will be the K inverse and K dash will be when you calculate it will the cancelled out. Only T, this part is left, and already we know that the skew symmetric matrix, when the right equipole E dash is given, we can represent in this form 0 minus Ez Ey. It is, we have studied many times this matrix. So again Ex, Ey, Ez are, it is given. So just put in this one, in this matrix, you will get directly the fundamental matrix. Okay. So Ez and Ey values is 0 because it is a Ey, Ez, and this Ex is 1. Just put all these values in this one, in this matrix. You will get directly the fundamental matrix because these two terms are cancelled out. So F is equal to only the pure rotation term, no translation, pure translation term. It is related to the pure translation only. So this will be the equal to the directly the skew symmetric matrix of the right epipole. Okay. Okay, so have you understand? Can we move to the next question?
Please proceed to the next problem.
Okay, okay, so next question is, consider a stereo setup with P and P dash camera matrices for left and right camera as given below. Here left and right camera matrices are given P and P dash. If the image coordinate of the 3D point are 4, 6 and 7.336 in the left and right camera, compute its depth, that is Z coordinate in the 3D. In the 3D we have to calculate. So already it is given P and P matrices, and now already we know that the what will be the homogeneous representation of these 2 points or 3D representation. Homogeneous representation of these two left and right image plane, image coordinate, homogeneous representation of these left and right camera matrices. You can say that 4, 6, 1. It is associated with left camera, right? And for right camera, it is a 7.336. 1. It is a homogeneous representation of the left and right camera, right? And let's assume that 3D point, let's assume that 3D point, let's representing it by a capital X, and it is X, Y, Z, 1. Okay, to compute the depth, its depth in the 3D. So projection equation, already we know that Px right? This is a projection equation. Our projection equation we have studied very in the I think third or fourth week. Projection equation. Just calculate for left camera as well as for right camera. Okay. So I'm just taking the next slide so that we can calculate. So projection equation for left camera, I can write it projection equation for left camera, and it is P into X. If the P matrix is associated with the left camera, yes, you can ask.
Madam, how do you know that left camera is 461 and right camera is
Yeah,
7.8
here
is
it is
661?
given. In the question it is given. It is question it is given.
Okay, okay.
Okay.
From these values
Here.
you have got this.
Yeah. It is question. In the question it is given. See, the image coordinates of the 3D point are 4, 6 and 7 in the left and right camera. So for first one is for left camera and second one is the for the right camera. Okay. And the this projection matrix, this P is associated with the left camera and P dash is associated with the right camera. Okay. Here it is given P
Thank you,
and
ma'am.
P
Sorry.
dash, left and right camera. So P matrix already here it is given 5 5 0 0 0 and 0010, and the 3D point for that we have assumed that x y z 1, right? So just calculate it. Here it is a 5x, right? Here the for the next one is it is a 5y and all other values are 0, and for the last one you will get the z. Okay, and already it is a projection equation for the left camera, and the point that is given here it is what is the point given in the 2D plane for the left camera, it is a 4 6, right? So that is equal to, or you can say the in the 2D image point for the left camera is given, that is 4 6, right? It is given, so we can convert it also into convert back and convert it in 2D this one. So how we can convert it? Just divide by this third and 5x divided by z and 5y divided by z, right? If we equate these two, 5x divided by z, 5y divided by z equal to 4 6. So we can find the relation between the x, y, z, and then again we have to calculate for the right camera itself. So from here, what relation we will get? 5x divided by z is equal to 4 and 5y divided by z is equal to 6. Okay, or you can say that here from x is equal to 4z divided by 5, or you can say the 0.8 z, and y is equal to 6z divided by 5, or 1.2 z, right? Now similarly you have to calculate for right camera also. Then we have to calculate the x, y, z values. So now the projection equation for the right camera.
Madam, can you please go back to the previous slide? I just missed that one.
Okay, yeah, sure.
Just 1 minute.
Yeah,
Yeah, thank you. Done.
okay. So you have any doubt or it's clear, right?
Yes,
Okay. So now projection equation for right camera. So projection equation for the projection matrix for the right camera, it is represented P dash, right? So P dash X, and that is equal to the given image point. So the projection equation for the right camera, it is given here the matrix, it is given in the question. Okay, 50010, then 05000010. Okay, so 50010, 0500, then 0010, and that x point we have assumed that xyz 1. Now just multiply with this one, so you will get 5x plus 10 right here in the first one. In the second row you will get 5y only. In the third one you will get z. Again convert it into the 2D, in 2D. So you will get the equation 5x plus 10 divided by z, and here 5y divided by z. Okay. Again in the 2D image plane, the right camera point is given already in the equation. Camera point it is given, that is 7 point, I think 7.33 and 6. So just equate with this one, 5x plus 10 divided by z, 5y divided z, that is equal to 7.33 and 6. Yeah, you can ask questions. 5x plus,
Madam, when you convert it to 2D,
yes,
5x plus 10 by z, 5y by z. How
yeah,
you got that, madam? Have you divided the two elements by z?
yeah. So
And what about
it
third
is,
element, ma'am?
uh, listen, it is in the homogeneous representation. If you have studied in the previous lectures in the week, I think 1, 2, or 3. So it is like that. It is a representation. So to convert it back into the 2D image point, so you have to just divide this. You have to make it one. So just divide it with this one and discard it. Okay.
Divide z by z, you'll get 1. 1 we have to discard, ma'am.
Yes, you have to discard it. You can discard it. Yeah. If it is asked that you have to represent it into a 3D, so you can take it like 1 also. If it is given into the 2D, so it is actually 2D image point. We can take it in the 3D itself, but 1 is equal to 1. That's why I have discarded. Because already in the first one I have told you, no, it is a homogeneous representation. Just we have added 1 here. So as we are adding 1 directly, so we can discard it also.
Yes,
Okay.
madam. Yes, madam.
Okay. So this one, so from here you can calculate it also the values. Yeah, 7.33 z minus 10 is equal to 5x, right? Or second value you have got 5y is equal to 6, right? So if you see that the it is equal to 6y5. The second point y is equal to 0, both are equal. Y is equal to 6z divided by 5 here you have got, and here also if you just solve it you will get the same values. Y is equal to 6z divided by 5, right? So that means y is equal to 1.2z. So we can't equate it. So just stick with the first one itself. So from the left camera, and also we have to just calculate
Madam,
only z value. Yeah.
excuse me. When z goes to right hand side, it will be multiplying them, ma'am. You have written divided by
Where?
7.3 7.33 by Z you have written. It should be
Oh, yes,
7.33
yes,
into Z, right?
yes, yes, yes. I have done this mistake. Let me calculate. So here you will get 7.33 Z again minus
Yeah, that's correct.
10 divided by 5. This is the correct value, right? For x. Yes. Okay. So from the left, I'm just removing it from. Can I remove it from here? Anyone of you have noted? All of you have noted down, or just I'm taking one more slide. Okay. From the left camera, x values what we have got.
And can you go back, please? I have not.
Yeah, just a minute. Yes,
Go to the previous slide, please.
yes. So for the left camera projection here x values that we have got 0.8 z and y is 1.2 z. That y values for left and right both cameras are equal. So just here first we have to calculate only for z coordinate the depth of the z coordinate. So here x is equal to 0.8 z we are taking from the left camera and then equate both the equations for left and right camera. Okay.
Okay,
So
ma'am. Then go
can
to
I
the next
move?
one. Yeah,
Yeah.
you can move on.
Okay. So the left from the left camera I can write from the left camera x values we have calculated 0.8 z, right? And in the right camera we have calculated the x value what we have calculated x is equal to 7.33 z minus 10 divided by 5, right? Yeah, 7.33 z minus 10 divided by 5. Just equate for the both x values for the left and right camera. Equate both the equation both x values. So can you calculate it and let me know what will be the value for the z minus 10 divided by 5. So here you will get 4z is equal to 7.33 z minus 10, right? Or you can write it 10 is equal to 7.33 z minus 4z, right? Or we can write it 7 minus 4, that is 3.33 z, or can directly write 10 divided by 3.33. Just if you divide it, we will get 3.003. So z value you will get 3.003. Okay. So at the end we have to calculate only z values, the depth of the camera as that asked in the equation, this one. So left and right camera compute its z depth, that is z coordinate in the 3D. So what value 3.003 we have got, that is option D. So option D is the correct answer for this question. Okay. So have you got this question? Z value that we have got
Yes, ma'am.
3.003. So option D is the correct answer, that is matching with the option D. Okay. Okay. So now moving to the next question. So now next question is, assume matrix A has following SVD decomposition. Can A be an essential matrix? Answer is yes or no. So matrix A has a following SVD decomposition. This one. Can A be an essential matrix? So how we can check whether A will be the essential matrix or not? So as we know that an essential matrix, let's say E, having the some properties, right? So the essential matrix E has a property that is E U that has a diagonal of S S 0 V transpose. Okay, and it must this is one is a one property for the essential matrix that essential matrix must carry the U that is a one decomposition of that SVD, then diagonal must be S S0 and V transpose. Okay, so S S0 for the next matrix. Okay, and it must have a two equal non-zero singular values. It must have two equal non-zero singular values. Okay, so here the SPD given SPD is in the form of, let's say, U. Let's say this one is a U matrix, and next one is that is diagonal SS0, that S can be any value. So here it is given 2 root 2 0 0 0 root 2 0 and 0 0 0, and this one is a V transpose, right? So what are the singular values of this one? So these are the singular values, that is S S in this one. So here 2 root 2 comma root 2, and the third one is a 0. So this is a 0, but these two values are not equal, right? These two values are not equal, but it must be in the must be a same value. It must be a equal value. So the first two singular values are not equal. So that's why 2 root 2 is not equal to that. These are the two different values. That's why that A should not be a essential matrix. So option B is the correct answer. So A here is not a essential matrix. Okay. Okay. So have you understand already SVD decomposition is given? We know that it is in this form. U diagonal and this diagonal should be equal. If this diagonal should be equal, then A can be a essential matrix. Okay, we can say that. So it is not following the property. That's why A can it is a not true. No. A be an essential? So A cannot be a essential matrix. Okay. Okay. So can we move to the next question? Okay. So moving to the next question now. So here the next question is given two corresponding points x is given 231 and x dash 571 and a fundamental matrix F with F33 is equal to 1, which of the following matrices satisfy the equipolar constraint x dash transpose F x is should be equal to 0. So already we have solved one problem based on that, right? So here the two image points are given in the homogeneous, already it is given in the homogeneous representation, right? X is given 231 and x dash is also given 571. Now the one constraint is given F33 should be 1. That means this one should be equal to 1. So in the all the options it is 1. So we have to check, and it should also must satisfy X dash transpose F X should be equal to 0. So again we will check with the options. Okay, so just check with the again options, multiply this X dash transpose F X and let's check whether it is coming equal to 0 or not. If it is equal to 0, that means that option is the correct one. So first we will check with the fx. For option A, we will check with the option A first. So first x dash transpose, that is 5, 7, 1, and F matrix in the option 1 is given 1, 0, minus 2, 0, 1, minus 3, 0, 0, 1. So this is a simple matrix multiplication, and can you also calculate and let me know which option is the correct one? So it should be faster, I think easier also, and you should also calculate. This is a simple matrix, not a large number. Can you calculate and let me know? X value is given 2, 3, 1. It should be equal to 0, right? So first calculate this one. So 5, 7, 1. Now next matrix what you will get? So 2, then 0, then minus 2, right? Now next one 0 plus 3 minus 3, then again 0, 0, 1. So here you will get directly, I'm just writing, so 0, 0, 1, right? So here you will get 1, not is equal to 0. So option A is not a correct option, right? Option A is not a correct option because this constraint is not equal to 0. It is coming 1. Now go with the second option. 0 minus 1, 1, 1, 0 minus 1, minus 1, 1, 1. Again, can you just multiply these two and let me know? So here you will get 0 minus 3 plus 1, right? So 2 plus 0 minus 1 and minus 2 plus 3 plus 1. So here you will getting minus 2, 1 and 2, right? If you multiply with this, you will get minus 10 plus 7 plus 2, right? So here you will be getting minus 1, right? That is also not equal to 0. So option B is also not satisfying this constraint, right? Now check with the options. Last one, option C, otherwise none of the above answer is the correct one. So 1 minus 1, 0, 0, 1 minus 2, 1, 0, 1. So just here you will get 2 minus 3. Here you will be getting 3 minus 2, 2 plus 1, right? Here you will get minus 1, 1, 3. If you multiply with this one, you will get minus 5 plus 7 plus 3. So you will get 5, right? It is also not equal to 0. That means option D is the correct answer, none of the above. That is satisfying the F matrix. If you want to find out the fundamental matrix that is F, so already I have told you how you will find that large one. You have to calculate by its own. Okay. Okay. So I hope you have understand. So now moving to the next question. Now next question is, which of the following singular value sets is a consistent with an essential matrix? So can you tell me which of the following singular value sets is consist with an essential matrix? So which singular value that SPD consists of essential matrix. So already we have solved this question, SPD decomposition. It is in this form, and it must be follow the two equal non-zero singular values. In this form, this is a U diagonal SS. That means it should be equal and one should be zero find the essential matrix, right? So from the options, can you check and let me know which option is the best? That is, essential matrix have two equal non-zero singular values and one zero values. So from the options you can check, or only option A have two equal non-zero values, right? Here two equal non-zero values and one zero singular values, right? This is it is also not incorrect because it has a two different values. Here it has two same values, but the third one is one. But we need a zero, right? Here also, so these options are correct. Only option A is the correct answer for this question. Okay. Okay. So have you understand this question? Okay. So I hope. Now moving to the next question. Now next question is two camera two camera have matrices in this form P is equal to K I given 0 and P dash is equal to K I given T with baseline length B is equal to 5 given an image disparity D is equal to 20 pixels and focal length F is equal to 1000. Compute depth Z. Okay, so all values are given. So to compute depth Z, the formula is already, I think we have established, F into B divided by D, right? F means focal length, B is baseline length, and D is the image disparity. All values are given, you can directly put it. So 1000 into 5 divided by 20, right? So if you just calculate, you will get 250. Okay, so here option A is the correct answer for this question. Okay, okay, so have you got this? Every value is here given, so you have to directly compute the depth. Okay, so moving to the next question. Now, next question is given camera matrices P and P dash for left and right camera. Find the word point depth Z for image point 400 and 300 and in the left and 360, 300 in the right camera. Okay, so how we can calculate it? That depth. Okay, so given P and P dash and left image point 400, 300 and right camera image point is 360 or 300, or you can say that we are representing it for the left U dash and for the right camera image point we can represent it by the U dash. Okay, and now let's assume that the image word point, let's word point is represented by capital X, that is equal to X by Z 1 transpose. Okay, now again from the projection matrix, that is we know that Px equal to in the 2D image point. So X we have assumed, P is given here, right? So 1000, 0, 320, 0, and 0, 1000, 240, 0, and again here 0, 0, 1, 0 into this one X, Y, Z, 1. Okay, so similarly that already we have calculated one question as same. So 1000 x plus 320z. Here in the next one, 1000y plus 240z. And the next one it is z, right? And we can equate it in the left 2D image point, that is 400, 300. Okay, that means it is a, you can say that it is a u and it is a v. You can say that here it is a u dash, here you can v dash. So let u is equal to, or not a u, or you can say that 400 directly. So 1000x plus 320z, or you can say that this image point, or you can represent it anyway. And we are not putting values, we can directly put here values or itself, or we can put it later. So I am just writing here directly u, because here we are representing it, this u. And also we have to represent it into the 2D image plane. So again divide it by z, right? And similarly for this one also. So 1000y plus 240z divided by z. Okay. Now similarly you have to calculate for right camera also, and you have to take u dash and v dash here. So I am just directly writing it here because already time is here. Already we have some questions. So I'm just directly calculated. So I'm writing here. So you can just multiply these two. Already p dash is given. X already we have assumed that x, y, z1, right? So if you multiply these two, you will get the matrix 1000 x plus 320 z minus 100 in the first row. In the second row, you will get 1000 y plus 240 z. In the last one, you will get z. Again, you can multiply with this divided by z, you will get, and equate it. We can, let's say that u dash in the first image point. So 1000 x plus 320 z minus 100 divided by z, and v dash 1000 y plus 240 z divided by z. Okay, so this one you can see that the v and v dash image point is also equal 300, 300, and v value is also equal 1005 plus 240 z divided by z in the left image point and as well as in the right image plane. So these are the equals. So the disparity, you can say that d, the d can be calculated on the left and right camera image plane u minus u dash itself. Okay, so from the left and right image plane, so just minus it, u and u dash. So u dash, u is 1000x plus 320z, 1000, let me just, x plus 320z divided by z, and u dash is 1000x plus 320z minus 100 divided by z, right? So if you just calculate it, so this value 1000x divided by z, and this will be cancelled out, you will get here directly minus and minus. So 100 divided by z, so d is equal to 100 divided by z, you will get here from the this one, right? Okay, so in general, if two image points are given, two image points are given, the disparity D is calculated by the U and U dash. Similarly, for this one, these points also we will calculate 400 minus 360. 400 minus 360. So from here D you will get 40. So this D and this D we have to equate it from the calculated value and for this one. So you will get directly the Z value 40. So Z you will get 100 divided by 40, right? So from here you will get disparity D is 2.5. Okay. So have you understand? So from the projection matrix, if the word point depth is given, so just assume that capital X and calculate left and right image planes and that values U and V and calculate disparity from here U minus U dash and the correct image points also D minus U dash. So from here you will get the disparity 40 and equate it with the this one what you have got in the equation form. You will get the jet plane coordinate or you can say the word point depth jet. Okay, so word point depth jet you will get here 2.5. Okay, so have you understand this question? Any doubt, anything, or shall we move to the next question? Okay, so now again this question is for SPD, singular value decomposition. So now it is given that calculate the third singular value of a matrix. It is given in this form A U. This matrix V transpose. Already we know that the singular this matrix is assuming it's valid essential matrix. So what will be the valid essential matrix? So already we know that the essential matrix must have singular value in the form of S, S, comma 0. That means these two values must be same and one must be a non-zero value, right? But here it is a 1, it is a not a non-zero value. So just it is a tricky question. It is a contradiction that third value should be a 0. So the for proper essential matrix, the third value must be a 0. So option A is the correct answer. For a valid essential matrix, the third value is 0. Okay, so calculate the third singular value for a matrix. If it is a 0, so it is a tricky here. 1 is given, so you should take for a valid essential matrix, it should be a 0. So for that, option A should be a correct answer. Okay, so this question is a trick. So already we have studied na, in this question itself. Two questions we have solved. This one for an essential matrix, the two properties that hold U, that means this matrix, and the diagonal 2 root 2 root 2 and should be 0 and V transpose it is in this form SPD decomposition and it is said that it must have two equal non-zero values. That means these two other two must be two equal non-zero values and the third one is should be a 0 value. Okay, and this one we have this one. In this question also we have seen that two equal non-zero values and one should be a zero value. So here the SPD is given in this form. So here the trick is applied because they have a assuming it's a valid essential matrix. So it is a non-valid essential matrix. If we want a valid essential matrix, so for that this two equal non-zero values should be there and one zero value should be there. So for that, for valid essential matrix, so third singular value of a matrix must be a zero. So that's why answer C is the option A is the correct answer for this question. Okay? Yeah. Okay. Now next question is in a stereo vision setup, what is the role of the plane induced homography H? So in a stereo vision setup, what is the role of plane induced homography? Any one of you can tell this for this question? Option A is it relates 3D points in the world to 2D image points. Or option D, it describes the transformation of a 2D points from one image plane to another, assuming the point lie on the single plane in a 3D space. Option C is it is a fundamental property of the camera independent of the scene. And or option D, it determines the extrinsic parameter of the camera, rotation or translation. So in a stereo vision setup, what is the role of plane induced homography? Anyone? Okay. So
B,
the
ma'am.
role of yes, yes. Someone is saying something.
And B.
Yeah, B. So the role of plane induced homography H is it is a homography is a planar projective transformation. Already we know that in the context of the stereo vision, a plane induced homography is a specific type of homography that relates image coordinates of a point in one camera view to their corresponding coordinates in a second camera view, right? With a crucial assumption that 3D point lies in a single plane in the real world. Okay, so that's why the option B is the correct option. And other options that describe that is camera projection, intrinsic properties, and extrinsic parameter. So option B is the correct answer. It describes the transformation of the 2D point from one image plane to another, assuming that point lies on the single plane in a 3D space. Okay. So now next question is Harris measure is invariant to 2D rotation. I think this is related to the another next week. So if I mistakenly it has came. So you can just take it. Harris measure is invariant in 2D rotation. So basically a Harris corner detector calculates the corner response mainly based on the eigenvalues of the second moment matrix, that is mm. It is represented by mm, and it is which represents the intensity variation in a small window of the image. So under the 2D rotation of the image, the eigenvalues of second moment matrix remains unchanged. Only the eigenvectors rotate accordingly. So for that, Harris corner response depends on the eigenvalues. It is invariant to the 2D rotation. Okay. So Harris is not a scale invariant. It is a sensitive to zooming and resizing. Okay. So Harris measures the invariant in 2D to 2D rotation is, I think, invariant to 2D rotation is true. Okay. I think you will study about this one next week. By mistakenly, I have taken in this week. So just you can ignore it also. Now the next question you can just go consider the following matrix F and the camera matrices P and P dash for the left and right camera given is fundamental matrix F is given, P and P dash for left and right camera matrix is also given. So the statement is which of the following statement is are true? P and P dash are compatible with F as a fundamental matrix. P and P dash are not compatible with F as a fundamental matrix. Or option C, given the fundamental matrix F, the pair P and P dash are unique up to a projective transformation. Or option D, P and P dash is defined a unique fundamental matrix up to a overall scale. So here F and P dash is given. Now we have to conclude which options are the true. Okay, just going with the solution. So B and D are the true. P and P dash are compatible with F as a fundamental matrix. So for the two camera to be compatible with fundamental matrix F, there must a 3D reconstruction such that projection relation holds F is computed from P dash. So the standard formula already we know that F is equal to E dash X, where it is a skew symmetric matrix, or you can say that of the right epipole, and P plus it is denoted pseudo inverse of a P. Okay, so if you calculate this one, that will not hold P dash P plus. So so arbitrary camera matrix and given F is rarely compatible unless constructed specifically together. So without more, this is false. P and P dash are not compatible already as we have with the fundamental matrix. So this is a contrapositive of A. So this one is a true. That means P and P dash is not compatible. And next one is given the fundamental matrix F, the pair P and P dash is unique up to a projective transformation. So in a given fundamental matrix, there are infinitely many possible pairs of projective equivalent cameras. The pair is not a unique. There are many such pairs related to the projective transformation. So this is also a false one. And P and P dash is a unique fundamental matrix up to a overall scale. So for a fixed camera matrices, one and only one up to scale funda matrix is determined, can be determined. So B and D are the correct option. That is P and P dash are not compatible with the fundamental matrix F, and P dash define the unique fundamental matrix itself up to a overall scale. Okay. So these are the questions for this week. I hope all of you understand these questions. So thank you everyone. Thank you for the joining this session. If you have any doubt, you can ask. Otherwise, we can close the session.
Thank you so much, ma'am.
Yeah, thank you. Thank you everyone.
And
Thank
what
you
all
for joining this session.
excellent session, ma'am, for today. Thank you so much.
Okay, thank you.
And next session will be on Saturday only.
Yes, yes. Saturday, same time.
Okay,
My
ma'am.
session
Thank you
will
so
be
much.
same day and same time. Okay. So if
Madam,
you don't,
can we get a recorded version of this session, ma'am?
yes, yes, you will get. You will get. So already you
Okay, ma'am.
have been shared all these details. Also, I think already
Yes,
I
ma'am. Thank
have posted. Um, so should I need to post that one?
you. Yeah, please, ma'am. Please.
So give me some time. So are you able to see my screen or not?
See, able to see, ma'am.
Okay. From this link, you can access all the videos, materials, and everything for all the TAs. So my name is Pooja Verma. So in my tab, you will get all the recordings and my presentation and the questions details. Okay, from this spreadsheet. Okay, so if you have any question or doubt, you can ask. Otherwise, we can close the session.
Ma'am.
Okay, so you can leave the session now. If you don't have any doubt, you can leave the session. Otherwise, you can ask your doubts or questions. Anyone else? If you have any doubt. Okay, can we close the session? Yeah, Swati and Sarat. Can we close the session? Or you have any doubt?
So I have few doubts, but can I mail you somewhere because time is already over,
Oh,
I think.
that's fine. If you want to ask here, you can ask. Otherwise, I am giving you to my mail ID. You can mail it. Okay.
Okay, so most important matrix concept like skew symmetric matrix, adjacency. So which all concepts are required to understand the stereogeometry?
Okay. Which concepts are required? Okay.
Yeah,
So
matrix
basic,
concepts. Yeah.
yeah, basic algebra you are required. I mean, like inverse matrix calculation to matrix multiplication and how you can calculate the inverse. Basically, inverse matrix calculations are more basic algebra, matrix multiplication, addition, subtraction, and finding inverse.
Okay.
Only these concepts are required, and some formulas that you will be getting through solving the problems or in the question. I mean, weekly content from itself. These are the some formulas are there. Na? So basically, that image is related to the matrix, right? So every
Yeah.
image is related by a matrix. It is represented in the form of matrix itself. So matrix is important. Finding out inverse. So for calculation in inverse, like you need to find out the determinant of the matrix. So you need to know that one, how to find the determinant of the matrix, how to find out the cofactors, and how to find out the adjoint or inverse. So already told you, na, I mean, ki how to find out the inverse of the matrix. So
Yes.
it is a basically adjoint of that matrix divided by determinant. How you will finding out the adjoint? It is just simply find out the all the cofactors of the matrix and take a transpose of the matrix.
Okay. Got it.
Okay.
And
Okay.
also, you were explaining some questions where we have to evaluate each option, right? And
Yes,
then we
yes.
have to see whether it is equivalent to zero or not. But in exam, we have very limited time, no? We
Yeah,
cannot.
correct.
So, is there any alternate option to do that?
So I think you didn't join the before the session little bit before. So that question is actually very thorough or very lengthy. This that question you can just that will be this is the shortest one. Go with the options. Okay,
Okay.
like this one. Otherwise, the other way to solve this question is very lengthy. I started solving, but it will take us so
Mm-hmm.
much time. So that's why I have I have another question itself. So let
Sure.
me go with that one.
Thank you.
Okay. Hello, are you in the meeting? Yes, Ati. So that one is the same question. So you can solve it this way also. F is equal to already we know this. This is a equation for the fundamental matrix E dash X into H. Homography matrix H is given. E dash X you can find out. So from here you just multiply these two equations and just find out the equations and calculate E2, E1 and E3 values. Then directly you will get the all F values for this, but this will be a very lengthy process. So going with the option, this type of question is easy, the easy way. Okay,
Okay.
yeah, because one is none of the above, and you have to check with the these three. So just do your calculation fast. So this is the
Yeah, so
main thing.
sometimes the two options are mostly similar. So
Yeah,
rather I spend time in calculation if I just exclude other two options which are not similar and I will just
yes, yes, yes.
uh,
Just calculate with this. So you have to take a shortest path. So you have to just use your, I mean,
mhm.
the options and mind, so which will give you a correct one. So just go check with that option and pick it. If it is giving that equation constant equal to zero, that is x dash transpose fx is equal to zero, that means that option is the correct option. Okay,
Yes.
okay.
Thank you.
So already I have given you the email ID in this
Yeah.
chat box. So if you have any doubt, you can mail them. Okay. So okay. Anything else?
I'm fine for now.
Okay. 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 Then thank you. Thank you for joining the session. Now the next class is the same time and same day. That is Saturday 6 to 8.
Sure.
Yeah, okay. Thank you everyone. Thank you for the joining the session. Now I'm closing this session.
Yeah.
Okay.
Bye.
Okay. Bye.